In this video, we'll be talking about matrix addition and scalar multiplication. Now, by definition, if we have matrices A and B, both of which have to have dimension m and m by n, then their sum is given by the sum of the individual entries. Now, if A and B are both matrices of different dimensions, then their sum is undefined, meaning that we really need to make sure that two matrices have the same dimension before we can try to add them. So for example, let's go ahead and find each of the following sums. Well, again, addition, when you know that the matrices are the same size, the addition of the two matrices is just the adding of the individual terms. Namely, this will be -1. The first entry will be -1 plus 1. The first row, second column entry will be 2 plus 3. The second row, first column entry, is going to be 0 plus -1. And then the second row, second column entry will be 1 plus 2. That is, -1 plus 1 is 0, 5, -1, and 3. So again, all we really did here was add each of the individual terms, right? Well, that makes this really easy. First, we can add these because we have, they have the same dimension. And in fact, we'll get 0 plus 0, which will be 0. 1 plus 0, which will be 1. -2 plus 0 will be -2. 1 plus 0, which is 1. 2 plus 0, which is 2. And 3 plus 0, which is 3. This even follows for this for column matrices as well. So here, again, they have the same dimension. They're both 3 by 1, right? So these were both 2 by 2. This is good to know. These are both 2 by 3. And these are both 3 by 1. And so we can actually add them, and we have 1 plus -1 will be 0, -3 plus 3 will be 0, and -2 plus 2 will be 0. Finally, here we cannot add these two, and that's because they are actually of different dimensions. This is a 3 by 3 matrix, whereas this is a 3 by 2 matrix. And as we saw before, as we saw in the last slide, when you have two matrices whose dimensions are different, then their sum is undefined. So this is not possible, this addition. And now it's your turn to try an example. So go ahead and perform the following additions with these matrices. On the count of 3, I will reveal the solutions. 1, 2, 3. So here we see that both these matrices are 2 by 2 matrices, so they have the same dimensions, so we can add them, which is given there. Similarly, these are both 3 by 2 matrices, so their addition is given there. This one is a 3 by 3, but this one's a 2 by 3, so the addition is not possible because they have different dimensions. And finally, we have two 3 by 1 column matrices, so their addition is given by that. So before I go too far into scalar multiplication, I do want to note something interesting. If we thought of 2 times a matrix A, B, C, D, that would be, normally that's 2 times that matrix, but it would be it added to itself twice. A plus A, B plus B, C plus C, and D plus D, using addition. But because of that, it's not too hard to see that you would expect that really what that gives us is 2A, 2C, 2B, and 2D, right? 2D. All right, but namely, if you look at this way, you say, oh, well, it looks like sort of the 2 got distributed to each of the entries. Well, this is how we define scalar multiplication. So, if A is an m by n matrix and C is a scalar, then the scalar multiple of A by that number C is the m by n matrix CAIJ. And it's interesting to note here that really this is why we call these scalars, because they sort of scale the matrix by C, okay? So that's why we call numbers just scalars. Here we can use this further to define the negation of A as negative A, so that's the negative of the matrix A, but we're going to define it as negative 1 times A. And this is nice because then we thus have subtraction. Really, what subtraction is it's A plus negative B. So I'll say A minus B. A minus B, which is A plus negative B. But we could also think of that as A plus negative 1 times B. So let's do some examples of computing with matrices. So suppose we have these 2 matrices, and we want to find 3A, negative B, and 3A minus B. Well, for part A, 3A is just 3 times the whole matrix, 2, 2, 4, negative 3, 0, negative 1, 2, 1, 2. It's 3 multiplied through that, and scalar multiplication by the scalar 3 just sends 3 into each of those. So we have 3 times 2, 3 times 2, 3 times 4, 3 times negative 3, 3 times 0, 3 times negative 1, 3 times 2, 3 times 1, and 3 times 2. But that just gives us 6, 6, 12, negative 9, 0, negative 3, 6, 3, 6. So that would be 3A. Well, B, we just take the negation. The negation just puts a negative on all of those. So negative of 2, 0, 0, 1, negative 4, 3, negative 1, 3, 2 just applies a negative to everything. So negative 2, 0, 0, negative 0, negative 0, negative 1, negative, negative 4, negative 3, negative, negative 1, negative 3, negative 2. And so if we clean that up just a tiny bit, we get negative 2, 0, 0, negative 1, positive 4, negative 3, positive 1, negative 3, negative 2. Now for part C, you may look at that and think, oh, that's going to be a lot of work. But we already calculate 3A and negative B in parts A and B. And so really what we have here is we just have 3A, which was this matrix, plus this matrix. Sorry. Negative 1, 3, 1. And you may be asking, why is it addition there? Well, it's addition because 3A minus B is 3A plus negative B, right? And so because of that addition in between those two, we're just taking 3A and adding it to negative B. And we know how to add now. We know how to do that. That's going to be 4, 6, 12, negative 10, 4, negative 6, 7, 0, and positive 4. All right, so there we have it. Now it's your turn to try an example, so go ahead and repeat similarly the process that I just did. On the count of 3, I'll reveal the solutions. 1, 2, 3. So here, I want you to notice that you can do subtraction actually entry by entry as well. You could do it the other way I showed, but this way works as well, and so you get that. Here, this is similar to a problem we already worked. And then this one, what I did is I already calculated 3a in this step, but I haven't calculated 2b, so that's minus 2 times b. But then what I went ahead and did was I distributed negative 2 through all this, so that becomes an addition, and I just performed the addition. For more practice in working with addition and scalar multiplication, be sure to see the textbook and work the problems on page 564 that are suggested. In our next video, we're going to talk about matrix multiplication.